I'm so excited for this to be your last chapter. I can't believe we've come all the way. Okay, so we need to teach you or remind you how to do quadratics before next year because you're going to be quadratic crazy next year. First of all, they talk about finding the greatest common factor. So if you're finding the greatest common factor, I always look at my numbers first. So looking at the numbers, what is my GCF between these two numbers? Hopefully you said 5. And then I look at my variables. What is the greatest that they have in common? And hopefully you said 1x, they have in common. So what I'm going to do is I'm going to divide each of these by that greatest common factor of 5x. So he comes out of the equation. And then I divide. So 15 divided by 5 is 3. X divided by x cancels out. 25 divided by 5 is 5. 2x's divided by 1x, if you remember, we subtract 2 minus 1, will leave me with 1x. Now, I can check my work by redistributing this to see if I come back to that original statement there. Okay, next one, greatest common factor. 3. How many x's do they share? 1. How many y's do they share? 1. So I'm going to divide both of these out by 3xy, 3xy. Take out the 3xy. What am I left with? An x there. And then here would be 4y. And again, I can redistribute it to get back to the original. Next, GCF. I was going to say 6. I think it's 6. X's, yep, they all have an X. Y's, they all have a Y. So I'm going to take out 6xy, 6xy, 6xy. I do it this way because it reminds me to do each one of those. So let's take it out. And I've got a good visual here. And that one's y to the 3rd. And again, you can double check yourself by redistributing. Next, 3 A's, yes. My B's, it looks like everybody has at least 2 B's, so that's a little bit different. So we're going to take out 3AB squared. 3AB squared. Okay, so let's take out that 3AB squared. What am I left with? Everything cancels, so that leaves me with 1. Plus 5a plus 9b. And there we go. Now on this next one, we're going to go ahead. So you have an assignment like this. And you're going to have to write these out. So, and then if you have an exponent, like you would write it out like this. Caret key to the 2nd power. So just FYI when you're doing that. Some of those are longer, some of them are shorter, but it should go pretty quickly. Next, the difference of perfect squares. And again, it might be a while since you've thought about perfect squares. A perfect square is like 1 squared, or 2 squared, or 3 squared, or 4 squared. 1 square is just 1 square. 2 square means it's 2 by 2, which makes a perfect square. This one would be 3 by 3, and then 4 by 4. So this is 1, that becomes 4 squares. This is 9, and then that would be 16, and then 25, 36. You should have your list of those and know those perfect squares. So this is a way to factor, and it's kind of like a shortcut. And it only works if it's the difference of. So if it's subtraction. If it's not subtraction, like this one, it's not going to work. Okay, so this one, all you're going to do is take the square root of each one of those. Take the square root of each term, but your answers would be a positive and a negative. So this is going to be m, so the square root, separating m times m squared. Square root of 64 is 8, so we're going to have a positive 8 and a negative 8. The reason why we have a positive and negative is because these two multiplied gives us that. foiling, multiplying these things together. Remember, you would just distribute. So this times this, this times this, this, and then this. Anyway, another time. So perfect square, subtraction. So this becomes 4y plus 9, 4y minus 9. Again, super simple. Perfect squared. 5a plus 6, 5a minus 6. Next. Can't do it because of the plus. So no can do. This one, perfect, oh, he's not a perfect square. Not perfect square, so it doesn't work. Now I could take out a 2 here. Is that right? Take out a 2. But it's not going to be the differences of perfect squares. So that's not going to work here. Okay, so let's try, well, let's go ahead and take that 2 out. 2x squared minus 13. So it would look like that. And this one, what goes into both of these? Does 4 go into 81? No. 2 doesn't go either, so I think that's a no-no. I think that's simplified as it can get. So this one, we have a GCF first. These are not perfect squares, but I have a GCF. And 3 goes into both of these. So let's take out a 3. If I take out a 3, I'm left with 4y squared minus 25. Now I see that this is a perfect square. This is a perfect square. So I'm going to take out that 3, and then I would go square root of 4 is 2y plus 5, 2y minus 5. And there you go. All right, that's all I got for you.